All right, guys, here we are in intro part 4. All right, we're going to look at the combined gas law. This is on page 450 in your textbook. So the combined gas law, of course, puts all the components of Boyle's law, Charles' law, and Gay-Lussac's law together. So the combined gas law is, so there's Boyle's law. And then, of course, that's Charles' law, V1T1. And that's Gay-Lussac's law. Oh, you can't see that. That's Gay-Lussac's law, P1 over T1. All right, so T2. Now here, our chart's going to be longer, right? We have 6 variables. You will have to know 5 of them. You'll have to know 5. You can't solve this if you don't know all 5 things. So you just have to put them in the correct spot when you're answering these questions. So it's really just a matter of good housekeeping. So we're going to solve number 11 on page 450. A sample of air in a syringe. All right, so much like maybe this type of syringe, okay? So we've got some air inside a syringe that can be closed off. So air inside a syringe exerts a pressure of 1.02 atmospheres. So that is my first pressure, 1.02 atm at, so that's my T1, at 22 degrees Celsius. The syringe is placed in a boiling water bath at 100 degrees Celsius, and the pressure is increased to 1.23 atms by pushing the plunger in, which reduces the volume. Okay, so now let's read. What was the okay, so you see here that what was the initial volume? That means we do not know V1. Initial volume means what did the volume start out at? So now let's look at our changing circumstances. I'm going to go in the same order here as we listed those. The syringe is placed in a water bath and it goes to 100 degrees Celsius. And that was a 0.0. The pressure is increased to 1.23 atm. All right, and it says it reduces the volume. So the pressure went up and the temperature went up. So the temperature should make the volume increase. But the pressure also went up, so that makes a change. So it's telling us that the volume reduced the volume. So the volume went down to this, 224 milliliters. What was the initial volume? All right, so now we're going to take this. So again, let me walk you through the way that your book would show you to do this. This means we're solving for V1. So we would rewrite our formula. V1 equals P2, V2, T1, because those have to be multiplied by each other. And then we're going to divide by everything that might be connected to the unknown. So we get divided by P1 divided by T2. And really, I'll just tell you the reason I don't like this is because it feels like I've got to memorize a whole bunch of equations when I really just have this one. And if I can understand the math up here, I mean, it's not really because we're just rearranging algebra. We're just using algebra. Algebra is our friend here to rearrange. So let's plug, what else do we have to do? Do you see it? We need to change our temperatures. We can't just, so we've got to say plus 273 here. So 22 plus 273, giving you a chance to grab your calculator as well. So that's 295 Kelvin. And then we have to add that here, plus 273. So our new temperature is going to be 373 Kelvin. Right? So now I'll drop down here. so that I'm going to actually pull this over here, okay? So V2 equals, pressure 2 is 1.23 atm. Volume 2 is 0.224 milliliters. Temperature 1 in Kelvin is 295 Kelvin. We're going to divide that by P1, which is 1.02 atm, times 373 Kelvin. Now, here is what I'm going to encourage you to do. You could certainly multiply these and write it down, and multiply these and write it down, and then divide those two numbers. But if you do that, then you run the risk of losing sig figs or making a transcription error. So what I encourage you to do is let the calculator do the heavy lifting here. The main thing you have to understand is these numbers are divided by this and divided by this. That's what would happen if we did the product here. So it's not divided by this one, then multiplied by this. It's divided by each of these two numbers. That is the number one mistake that students make at this level, is they forget that both of these are divisors. So let's pump these into the calculator, into our chugga train here. 1.23 times 0.224 times 295 equals, don't care, not going to write it down, divided by 1.02 divided by 373 equals. Now I have 0. And I'm going to look back, I can have 3 sig figs, right? 0.214 milliliters. Okay? You can check it out. If you multiplied all of these, made a note of what that was, or let that hang out in your calculator, multiply these, and then you divide the numerator by the denominator, you will get the same answer. So here is our answer. Now, let's just see real quick, what would this look like with the Fraser, I'll call it the Fraser shortcut, even though we don't really love that idea. Let me pull this out so I can refer to it right here. Same problem. Oh, there we go. Same problem, but just going from my charted information straight from here. So I'm just going to write this down. You would already have this written on your paper. Equals P2, V2, T2. So all I'm going to do is fill in my data. So the first, pulling this from before, right? The pressure 1 is 1.02 atm. The first volume, I don't know. And then the beginning temperature is 295 Kelvin equals the pressure changed to 123 atms. The volume changed to 224 mLs. And then the temperature changed to 373 Kelvin. This would be enough work. If you did that, that would be enough work if you come up with the right answer to show what we have. So now let's look at our, since this is set across an equal sign, we're going to cross multiply, right? I'm going to start on the side. I'm going to save this guy to last, right? So that means I'm going to multiply these, and then this number and this number become my divisors because they'll be connected to my unknown. So we do this again. So I can start here, 0.295 times 1.23 times 0.224 divided by 373 divided by 1.02 equals, ta-da! Volume 1 equals 0.214 milliliters. Atmosphere cancels. Kelvin cancels. Milliliter is my unit that's left, so that's the unit that has to be on my volume. Your task now is to solve number 12 on page 450 and to solve number 18 on page 451. So that gives us 6. You have 6 problems to solve and upload in one set related to these videos. We'll be looking at more ways to use these gas laws and solving more problems together as we go along.